Putting this all together, we're going to add a new Letrec core form demo, not just handled in the parser. I'm also going to add if zero, because it's useful to write interesting examples, ones that don't just loop forever, to have a conditional in our language. And the code is the same as the just lambda interpreter, except with if zero and letrec, and with our binding type changed so that we have a function that returns a value instead of an immediate value. Inside interp, we have a case for if zero, which is straightforward. Letrec here I've written slightly differently than on the slides. So here I have two definitions that can see each other. New environment that I need to use twice, one for the right-hand side and one for the body, and then the value which we get by interpreting the right-hand side using the new environment. Meanwhile, new environment is written with this delayed reference to value inside of a function inside of bind, but the extend dim can complete because we won't refer to val too early. With that definition of letrec, and of course with lookup updated to call the function when we get it out of a binding, then we can try running an example like the factorial function. So here when I run factorial of 5, I get 120. So that demonstrates that this version of letrec works at least as well as the one we had when it was handled just in the parser. In fact, it can do more because we can try an example like this, letrec x equal 10 and x plus 1. That kind of thing would work in Shplait. It now also works in Mo because this version of letrec does not require that the right-hand side is a function. We could make some other recursive functions to try this out. I'd like to make one further point though, try out one more thing, which is to say letrec x equals x. Now this is a too early use of x, right? In this case we should get an error or something about a too early use of x because it can't make sense. When I actually run it, I do get cannot use before initialization, but it talks about val, and it's at the Shplait level. So this reflects something unsatisfying in general about using Shplait's version of something to implement Vo's version of something. We don't get full control ourselves. We don't get to raise this error about use before initialization and talk about the right name. And we haven't really necessarily understood how Shplait is doing the recursion when we implement it ourselves. So our next step is to take more control and not rely on Shplait's letrec to implement Mo's letrec.